Welcome to Code with Vinay. In this video, I'll be solving the ISC 2023 Specimen Computer Science Paper 1 for you. More than the solution, it will be about how to approach the paper and the thought process. There are several advantages to attempting a specimen paper of an examination, like familiarity with exam format. Specimen papers provide a valuable opportunity to become familiar with the format of an exam, including the type of questions that will be asked, the length of the exam, and the way in which the questions will be presented. It helps you practicing time management. Attempting a specimen paper can help you practice time management skills. You'll have a limited amount of time to complete the paper, and attempting it will help you to understand how much time you need to allocate for each section. It helps you in identifying knowledge gaps. Specimen papers can help you identify areas where you need to improve your knowledge. If you struggle to answer certain questions or sections, you can focus on those areas in your study and revision. It helps you in boosting confidence. Attempting a specimen paper can help you to build confidence and reduce anxiety about the real exam. By becoming familiar with the format and the type of questions that will be asked, you will feel more prepared and confident on the day of the examination. If you have access to a teacher or a tutor, attempting a specimen paper can provide an opportunity to get feedback on your performance. They can help you to identify an area where you need to improve and provide guidance on how to approach the exam. Overall, attempting a specimen paper can help you feel more prepared and confident for the real exam and can be a valuable tool in your exam preparation. Let us understand the format of the paper. The entire paper 1 carries 70 marks and is to be attempted in 3 hours. Let us understand the format in slightly more detail. Part 1 will carry 20 marks and will consist of compulsory short answer questions testing knowledge, application, and skills relating to the entire syllabus. There will be 2 questions in this section carrying 10 marks each. Part 2 will be divided into 3 sections A, B, and C. You will be required to answer 2 questions out of 3 from section A, each carrying 10 marks, and 2 questions out of 3 from section B, each carrying 10 marks, and 2 questions out of 3 from section C, each carrying 5 marks. Therefore, a total of 6 questions are to be answered in part 2. Observe the instructions after part 1. The instructions clearly says, while answering questions in this part, indicate briefly your working and reasoning wherever required. Make it a point to follow this. The problem with attempting these short questions mentally is that sometimes we overlook things or miss steps resulting in loss of marks. It invariably happens that if you make a common mistake, the corresponding wrong answer is also present as one of the options of multiple choice questions. Also, in non-MCQ questions, even if the final answer is wrong due to a mistake in one of the steps and you have shown the working, there is a high probability that you will get some marks. So do show the working in brief as far as possible instead of directly writing the answer. Now let us explore the actual questions of the specimen paper. We'll walk through all of them one by one. Question 1, part 1. The question is, the law which states A plus B dot C is equal to A plus B dot A plus C is, and that is followed by 4 options: associative law, distributive law, involution law, and commutative law. Recall that the term distributive comes from the fact that the operation on the left hand side distributes over the term on the right hand side, allowing us to expand or simplify expressions. What I mean to say is that the operation on the left hand side, that is plus, distributes over the terms on the right hand side. So this plus is getting distributed over the terms on the right hand side. Hence, the correct answer is B, distributive law. Part 2 of question number 1 is asking for the dual of P plus P complement dot Q plus 0 is equal to Q. The dual of a Boolean expression is obtained by interchanging and or operations and zeros and ones. That is, wherever we'll have a plus, we'll replace it by a dot. Wherever we have a dot, we'll replace it by a plus. The same will happen for 0 and 1 as well. So 0 will be replaced by 1, 1 will be replaced by 0. Note that complements are not touched. So going by this logic here, this plus will become dot, this dot will become plus, this plus will become dot, this 0 will become 1, and rest of the things will remain same. So if you notice, p dot p complement plus q dot 1 is equal to q. Hence the correct answer is A. Now let's move to part 3 of question number 1, and this question says the complement of the Boolean expression p dot q whole complement plus r complement is, and then there are 4 options. Let us solve this. So our expression is p dot q whole complement plus r complement, and we have to find the complement of this expression. So we'll apply De Morgan's theorem. De Morgan's theorem states that the complement of the sum of two variables equal to the product of the complements. That is, this plus will become dot, and then p dot q complement dot r double complement, and then by law of involution these double complements will vanish. So we'll get p dot q dot r. Hence the correct answer is B, that is p dot q dot r, or simply pqr. Now we come to part 4 of question number 1, and this question says if x implies not y, then its inverse will be, and then that is followed by 4 options. To find the inverse of an expression, we need to invert both the left hand side and the right hand side of the expression. So here the expression is x implies not y. If I invert this, I'll get not x. If I invert the right hand side, I'll get y. And if you see, the correct answer over here is not x implies y. So the correct answer is D. Part 5 of question number 1 is transitive nature of inheritance is implemented through, and the 4 options are single inheritance, multiple inheritance, hybrid inheritance, and multi-level inheritance. So multi-level inheritance is a type of inheritance in object-oriented programming where a derived class inherits properties and methods from base class, which in turn inherits properties and methods from another base class, and so on. This creates a hierarchy of classes where each derived class inherits properties and behaviors from all its ancestor classes. That is, there is a class C which inherits from class B, and then class B inherits from class A. So this is multi-level inheritance. Another way of looking at this question is that single inheritance only involves one direct superclass and does not allow for the transitive nature of inheritance. So single inheritance is ruled out. Multiple inheritance, on the other hand, is not allowed in Java, so multiple inheritance is also ruled out. Hybrid inheritance is a combination of single and multiple inheritance, and it also does not directly implement the transitive nature of inheritance, so this is also ruled out. So there were only 5 MCQ questions in the specimen paper, and now remaining question of part 1 will be short answer type questions, and we'll be doing them one by one. Part 6 of the question number 1 is write the canonical sum of product form of the function y of ab equal to a plus b. Canonical sum of product form means that the expression should be in sum of product, plus it should also be in canonical form. Canonical form means that each term should have all the literals. So in this function y, there are 2 literals a and b. And the first term, that is a, is missing the literal b, and the second term b is missing the literal a. In order to convert this function into its canonical form, both the terms should have a and b, either in complemented form or in uncomplemented form. So let's begin. We have a function of a and b called y, which is a plus b. Now, there is a property x dot 1 is equal to x. That means something dot 1 is equal to the same thing. So if I say dot 1 over here, the value of the expression is not going to change. Similarly, if I say 1 dot over here, the value of the expression is not going to change. Now, there is something known as law of complements, which states that x plus x complement is equal to 1. So here, in case of 1, we can introduce the missing term. We can say b plus b complement. Similarly, in case of second one, we can introduce the next missing term, that is a. So we'll say a plus a complement dot b. Now we'll expand. So we'll say a dot b plus a dot b complement plus a dot b plus a dot a complement dot b. Now idempotency law states that x plus x is equal to x. So here if you notice, a dot b is getting repeated. So we'll just write it once. We'll say a dot b plus a dot b complement plus a complement dot b. And now if you notice, each term is having all the literals. So there is a and b in complemented or uncomplemented form in each of the terms. Hence, this is the canonical sum of product, and this is our answer. Now let us see part 7 of question number 1, and the question is, name the basic gate that is equivalent to two NOR gates connected in series. So let us have two NOR gates in series first. So we have one NOR gate over here, and the output of this will go into the next NOR gate. So we have another NOR gate over here. So we have like this, and let's say the input to the first gate are x and y. So NOR means not of or, so we'll get x plus y whole complement, and this x plus y whole complement will go as the two input of the second gate. So the final output will be x plus y complement plus x plus y complement whole complement. That is the meaning of NOR. Now if you notice, x plus y complement plus x plus y complement over here, by idempotency law, a plus a is equal to a. So we'll say that this becomes x plus y complement whole complement, and then by law of involution, this double complement will vanish and we'll get x plus y. So the basic gate is an OR gate. The operation x plus y is nothing but an OR gate. So if this is x, this is y, this is x plus y. So the basic gate is OR, and hence the answer is OR. Now the next question, that is question number 1 part 8, is state any one purpose of using the keyword super in Java programming. One of the use of keyword super is to invoke one of the constructors of base class. For example, if I say super1, I'm invoking the constructor which is accepting one integer argument. Another use of the super keyword is to invoke a method defined in the base class. For example, if I say super.f, I can call the method f defined in the base class. Now the question is asking for any one purpose, and you are free to use either this one or this one. The 9th part of question number 1 is define interface with respect to data abstraction. And since it's just a 1-mark question, we'll give a very brief description. In Java, an interface is a collection of method signatures that defines a contract for how a user can interact with a class abstracting away its implementation details and providing a simplified view of its functionality. This sums up interface with respect to data abstraction in one line. The 10th and the last part of question number 1 is what is a linked list? This is also a 1 mark question, so we'll give a short and precise answer. A linked list is a data structure that consists of a sequence of nodes, each containing a value and a reference to the next node used to implement dynamic data structures. This short answer mentions all the important aspects of a linked list and should suffice for a 1 mark question. Now let us see question number 2 part 1. And the question is, convert the following infix notation to postfix form, and then they have given an expression p by q minus r whole multiplied by s plus t. In postfix notation, the operator comes after the operand and we'll begin with the highest precedence operator first. So in this question, the highest precedence is that of parenthesis followed by division in the case of first term. So let's first resolve p divided by q. So what will happen is that this slash will go after q. That is the first step. So p q slash. Once this is done, pq slash will be treated as one operand. That is, let's complete this first. So minus r into s plus t. So what I'm saying now is that pq slash is one operand and r is another operand. So now what will happen is that this minus will go after r. So it will be p q divided by r minus. This resolves the first part. Similarly, we'll come to the resolution of the second part, that is s plus t. So this will become st plus. So now this whole thing, that is pq divided by r minus, is one operand. St plus will act like another operand, and now this asterisk will go back. We have already moved this over here, so now the asterisk will move back. So this will become p q slash r minus s t plus asterisk. And this is our final answer. Do keep in mind that the postfix expression must not contain any parentheses. As soon as you resolve a set of operator and operands, make sure that you get rid of the parentheses. Now let us discuss part 2 of question number 2, and this question is a bit different from the regular one. The question states that there is a matrix of size 11 by 8, that is 11 rows, 8 columns, where each element requires 2 bytes of storage, and they have given the base address of the element at row 2 column 3, and the address of that cell is 2140. The objective of the question is to find the address of cell at row 7 column 5, given that the matrix is stored in row major form. Let us understand this with the help of a diagram first. So this is our array n. The number of rows is 11, that is 0 to 10. The number of column is 8, that is 0 to 7. And the interesting part is that the base address which is given is not of cell 00, but it is of cell 23. So the base address is of this cell. And the target cell that we want to find the address of is 75, marked by this green color. The address of a location ij in row major system is calculated using the following formula. Address is equal to b plus w into n into I minus lr plus j minus lc. Here b is the base address, I is the row subscript of element whose address is to be found, j is the column subscript of element whose address is to be found, w is the storage size of one element stored in the array in bytes, lr is lower limit of start row index of matrix, and lc is the lower limit of start column index of the matrix. M is the number of rows in the given matrix, and n is the number of columns in the given matrix. Note that LR and LC are assumed to be 0 when they are not provided in the question. which is also the case in this question because here also LR and LC are not provided. So we'll take them to be 0. So let us substitute the values in the formula. But before that, let me write the formula. The formula is address is equal to base plus width into n into I minus LR plus J minus LC. So address is 2140. Base address, that is the address of cell 00, is not provided. So we'll just keep the variable B over here. W is the storage size, that is 2 bytes. N is the number of column, that is 8 into I minus LR. I is 2, LR is 0, J is 3, LC is 0. Let us solve this now. So 2140 is equal to B plus 2 into 8 into 2 plus 3. 2140 is equal to B plus 2 into 8 to the 16 plus 3. 2140 is equal to B plus 2 into 19. That means 2140 is equal to B plus 38. And finally 2140 minus 38 is equal to B. Hence base address is equal to 2102. So now the base address B of the array n, that is this location, is 2102. Now we'll again use the same formula, but this time the value of base address is known to be 2102, and this time we'll find the address of 75. There is not much space left for doing the rest of the calculation, so let me make some space for doing the rest of the work. So what I'll do is I'll get rid of this portion. We'll move this up, and this gives us some space to proceed. So this portion was for n of 2, 3. And now we'll operate for n of 7, 5. So we'll need the same formula again. So we'll say that address is equal to B plus W into n into, since we know that LR is equal to 0, so I plus, we also know that LC is equal to 0, so just J. Now let us substitute the values. So equal to 2102 plus W, that is 2, into N, that is 8, into I, that is 7, plus 5, is equal to 2102 plus 2 into 8 into 7, 56, 56 plus 5, 61, which is equal to 2102 plus 122 is equal to 2224. Hence our final answer is 2224. That is, this location is 2224. Now let us move on to the next question, which is part 3 of question number 2. And here we have to find out the output of the given code snippet for a given value. So let's work it out. The value of n is 3269. So the first value is 3269. Then there is a variable a which is 1. There is a variable b which is also equal to 1. And then there is a loop variable I. The loop variable is being initialized to n, that is the first value will be 3269. And then while I is more than 0, we'll keep on dividing it by 10. Now I is an integer, 10 is also an integer. So integer divided by integer will give you an integer. So the next value of I will be 326, then the next value will be 32, then the next value will be 3, and then finally it will become 0. When it will become 0, the loop will finish. So the loop will run only till this point. Now within the loop we have a variable d, and d is extracting the last digit. I modulus 10 will give you the last digit. So first time the last digit is 9, then 6, then 2, then 3. Now we are checking for odd and even, whether the digit is even or whether the digit is odd. So if it is even, we are coming to this point. If it is odd, we are coming to this point. And then we are finding the product of even digits and the product of odd digits. So if you notice over here, the even digits are 6 and 2. The product will be 6 2s are 12. And even digit is being stored in A, so this will become 12. The odd digits are 9 and 3. The product is 27. So the output will be A, that is 12, space followed by 27. That takes care of the first part. The second part is, what is the method solve computing? The method solve is computing the product of odd and even digits separately. That's it. Now let us move on to the next question. The next question is, the following function quiz is a part of some class. Assume n is a positive integer greater than 0. Answer the given question along with dry run and working. Observe that the function quiz is being called from within the function quiz. That means this is a recursive function. This implies that the function quiz will call itself repeatedly till the given base condition is not met. The base condition of this recursive function is less than or equal to 1. That is, till the value of n is not less than or equal to 1, the function will keep on calling itself. Now let us see what happens when this function is called. The function is being called with the value 36922. Observe that when the function is called, the value passed is n. Then after checking the base condition, it will decrement that value of n, that is, it will go down by 1. Thereafter, we find the modulus 2 of that number, that is, whatever the current value of n is, that modulus 2. And finally, we are saying add this value to the value returned by the recursive call. The recursive call divides the number n by 10, that is, essentially it removes the last digit of the number. This means that with each recursive call, one digit will be removed from the end of the number. The recursion will end when the number becomes less than 1. So let us first see how the value of n will vary. So first time it will be 36922. Then it will be 3692, then it will be 369, then it will be 36, then it will be 3. Now please understand, 3 is not less than or equal to 1, so this will go till 0, and when it becomes 0, then the recursion will end. So when the value of n is 36922, the value of minus n will be 36921, that is 1 less. When it is 3692, then it will be 3691. When it is 369, it will be 368. When it will be 36, it will be 35. When it is 3, it will be 2. And since the recursion is ending at this part, it's not going below this. Now let us list the remainders which are supposed to be added. So first time, 3692 modulus 2 will be 1. This will go on to the stack. Then 3691 modulus 2, this will also be 1. Then 368 modulus 2, this will be 0. Then 35 modulus 2, this will be 1. And then 2 modulus 2, and this will be 0. And once the exit condition is reached, computer will go through these remainders in the reverse order because they are on the stack. and then it will be added up. And the final answer will be 1 plus 1 plus 1, 3. So this is how we find the value of quiz when n is equal to 36922. Now the second part of the question is very interesting. It is asking, state in one line what does the function quiz do apart from recursion. And now since the function quiz was returning 3 when the value of n was 36922, students sometimes wrongly infer that this is counting the number of even digits of a number. Please understand that this inference is outright wrong. And though one can give several other examples to show that it is returning the number of even digits, that is incorrect. While examples may provide evidence for a hypothesis, they cannot definitely prove its validity. No matter how many examples are given, they not constitute a comprehensive or conclusive proof. However, one example is sufficient to prove something wrong, and that is what I am going to do now. So let's call the function quiz with the argument 1. The number of even digits in 1 is 0. But when we call this function, as soon as the computer reaches this line, n is equal to 1, the value of 1 is returned and we get 1. And obviously the function is not returning the number of even digits. It is returning simply 0 in this case. Now coming back to the original question, what does the function quiz do? And the answer is, the function quiz does not perform any well-known operation. In one line, it accepts a positive integer and counts how many times the number 1 less than the argument is even after removing the rightmost digit till the number does not become 1 in the process. And in my opinion, since the function is not performing any well-known task, you will get marks on either of these answers. With this, we have reached the end of part 1 of ISC Computer Science Specimen paper of 2023 and also the end of this video. See you in the next video. Thank you for watching. Your feedback is valuable to me. I want to make sure that my videos are clear and helpful. You can follow me on the internet on any one or all of these channels.